got N is obviously. P is. Q is. Technically, I really couldn't tell what P was yet, but you can see it's all about smoking. You with me? So the probability of success has got to match what the question is looking for. So that's what a success is called. So that's why I said a success doesn't have to be a happy event. It's just what I'm looking for. Guys, girls, there you go. And then this guy, I didn't mean for this to be weird. I just didn't want to do work for you. This is just the random example. If I would have asked for 3, this is how you would have put it in the calculator. And then what'd you guys get? Let me try. Do it again.
0.0539.
0.539?
Yep.
Just so you can kind of see what it looks like. All right. So here's X is 7. So what do I pick here? I got 44 people I want to choose. 7 of them to be successes. So how many of these do I have? 7. And how many of these do I have? 37. So 7 successes out of 44. So I want 7 of these guys, and the rest are these guys. And what do you guys get for that?
0.161.
Yeah, that sounds right. Anybody have issues with that? You guys all right? Okay. All right. Here, the same idea. So I got 44 people still. Jeff, look at the paper. Oh, yeah. Choose how many?
0.
None. I like it. So how many successes?
0.
Nobody. How many failures?
44.
All of them. Real quick. What is anything to the 0 power? 1. How many ways is there to choose nobody from 44? 1. I don't want any of you people. There's one way to do it, right? So that's 1 times 1. So to be honest, you can just put this piece in. Let's see if I get the same answer you did. 0.848, right? To the 44th. Man, why are you so... What's wrong with you? There it is. You guys get that? Yeah. And how the hell do I interpret this? Well, the neat thing about scientific notation, when it's negative, I always have to move around the one number that's here, so there's going to be 1 less 0. So there will be 3 zeros in front of 7. Bam! And that should kind of make sense. It should be very unlikely, or rather unlikely, that there's no smokers out of a group of 44. There should be some. Now, here's my favoriteest thing in the whole universe, is this idea of, it's not even really just about at least 1, it's the idea of opposite probabilities. Help me out. Help me out. If I did probability of 0 plus probability of 1 plus probability of 2 plus all the way to probability of 44, what would I get? What would I get? If I add up all the probabilities, I have to get 1. Don't look at me like I'm crazy. We know this. If I add up all the probabilities in a situation, it must come out to be 1. As long as it didn't round. I'm not rounding anyway. So what would 1 minus this guy be? 1 minus him would be all the rest of this shit. What's a quick way to say all this shit? At least 1. So 1 minus none is the probability of at least 1. It just is. 1 minus 1 chunk is the other chunk. So anytime the opposite probability has less work to do, shit, yes, I'm going to do it. So let me see if I can push this. If the question would have been, what's probably, it's at least 2, I would have done 1 minus the probability x is 1 or 0. So I would have figured out 1, figured out 0, added them together, and then took 1 minus that. The probability of something is 1 minus the probability of the opposite. When do I want to do that? When the opposite situation has less work. That sounds good. We're not being lazy. We're just being efficient with our time. Yes?
You wouldn't make us ever do like halfway, right?
No. That would be kind of mean. And I'm not, like it referenced my earlier statement about I'm not quite there yet.
Are we going to run into a lot of problems with at least 2 or at least 3?
In the homework, there are a few of those. Yes. Okay. So this one is easy. 1 minus, we already know what this is. Bam. We already calculated that, right? So you get 0.9993. Kick ass. Kick ass. So there's an almost 100% chance that at least 1 out of 44 randomly selected people from San Diego will smoke. I think this isn't the most recent one of these. Right? I am lazy, so well. But I don't think it would have changed too much, but I'm not sure. This is maybe like 4 years ago. This was valid then. Okay. Now we just do this. What's N? Thank you, kids. What's P? And then what do you guys get for that?
6.
Okay. So from any group of 44 randomly selected San Diegans, I expect almost 7 on average from every group of 44. So here's the thing I was talking to somebody else about. If I flip a coin 100 times, 1, I got to worry about my life a little bit, but 2, how many heads would you expect to see? 50. If you saw 49 heads, would that freak you out? No. I didn't mean heads on the coin, not heads. If you saw 45 heads, would that freak you out?
No.
If you saw 10 heads out of 100,
A little bit.
maybe not freak you out, but like, would that be evidence something weird's happening?
Yes.
Yes. Is it impossible for that to happen?
Nope.
Is it unlikely for that to happen? Yes. So this last question, I haven't gotten the standard deviation yet, but oh well, too bad for us. This last question here is really about, okay, the mean is what I expect, but it's an average, so I should be able to be away from it. But how far away from it would unusual start? Like if Shaquille O'Neal took free throws. And he, across his career, made maybe 30% of his free throws if I want to be generous. And I know he was a Celtic, but it was primarily a Laker, and Lakers, bam. So if you like the Lakers, too damn bad. If he made all of his free throws after taking 20 free throws, that would be really unusual because I would expect him to make 30% of 20. So if he made all of them, I'm like, whoa, dude, you've been practicing too damn bad. You don't still play professionally. Sorry. It's like the shit on the Lakers winning. All right. So what is the standard deviation? This is this freaky little formula. 0.84. And what do you guys get for that?
2.381.
Ooh, neat. Dissension. Let me see. Here's how I would do this. So to get the mean, you got to do 44 times 0.152, right? Then I would take the square root of that times Q. So that's NPQ. Or you don't have to do that. I love how some of you guys look at me like I'm weird, but so 2.381. I like it. You could put a 5 there because I do technically say you have to be at least 3 places, but I'm not going to overachieve. Right? And now this is a question that's a little bit different. This is a question of what unusual is. So why does it make sense 2 standard deviations out is where unusual would start? Do you guys remember, we did talk about like the empirical rule, right? Did we talk about what percentage of a normal curve is within 1? 68%? Who remembers what within 2 steps was? 95. So tell me this, what percentage of data would be outside of 2 steps away? If there's 95% inside, 5% outside. If there was a 5% chance of something happening, would that be unusual to happen? Yes, that's where this came from. 2 steps away should contain most of the occurrences. Anything outside of that we would consider unusual. So imagine height. Average height for a man is 5'9". If I go 2 steps away, anybody outside of that is either really, really tall or really, really short, and it would be unusual. That's not something you see all the time, right? That's what this unusual means. Makes complete real-world sense. my hope. So in the middle goes the mean. Now I'm taking 2 steps though, right? So I'm going to add 2 of these. Where do you guys end up? 11.4, blah, blah, blah. And then take 2 steps down to where you end up. Who is it?
1.925.
I like it. So this is the range of smokers that would be usual to see from a group of 44. So if I took 44 people and 15 of them smoked, would that be unusual officially? Yes, that would be unusual. So you can imagine the same thing for the cancer cases. There would be an expected number of cancer cases, and then a min usual and a max usual, and then if I see something up here, that's a reason to go investigate. Something weird might be happening. It could just be randomly up there. You guys with me? Would it be impossible to get 15? If I flip a coin 50 times, is it impossible to get nothing but heads? Is that impossible? I love you guys. Of course it's not impossible. To be impossible, that would mean the coin would have to somehow know, oh man, I've already had a bunch of heads. I better flip over in this other one. Right? I mean, you guys, does that make sense? So is it impossible to flip 50 heads in a row? Of course not. Our brain can't quite handle very low probabilities, so our brain just goes, oh, impossible. No. So it's not impossible for 15 to be just randomly happening. But it is unusual because the probability would be really small to be way out here. So that would be evidence to go in and take a deeper look. Okay. Oh, let's see. Anything on this? I think we just finished it, right? Yes. Any questions on this sheet? All right. So now we're going to transition. I'm going to do a little bit of a preview of the next chapter. Chapter 6. Chapter 6 is not next. I just want to tell you, chapter 6 is probably the most important chapter in the book. All right. We're about to talk about chapter 5. 5 leads into 6. Here we go. Now realize me saying chapter 6 is the most important doesn't mean every other one is not important. They're all important, just 6 is a little bit more. Because everything after 6 is going to involve 6's ideas. It's all across all the statistics. We get the idea, Jeff. All right. So, if I say I have a dart board, right? Everybody knows what a dart board is? If you're not sure, it's just a board that you throw these sharp objects at, normally when you're inebriated, so should be a large, clear area. Okay. Too many people walking out of bars with darts sticking out their head. I got a what? Oh, dude, it's good. You got this little circle there, and you got these little pizza slices of things out here, right? And it's all the way around. I'm just not going to draw because that's about the extent of my drawing ability. So then you throw darts at this thing. There are a few different ways to play this game, but when I had a dartboard when I was young, we didn't do anything too fancy. It was just like whoever can get closest to the bullseye was great, right? So if you know darts, I'm not going to talk about all the freaking little rules and shit. No. Why do you think this little area would have kind of like the highest score possible?
It's the smallest area.
Smallest area, the least probability. Right there, inherently, there's a connection between area and probability. If I just blindly threw darts at a dartboard and only count these, I'm not going to count. Are you guys with me? They're not even going to count at all if I miss it. I'm only going to count the ones that land here. There should be very few of them landing right there, just probabilistically. It's just a small area. You guys kind of with me? A little bit. Okay. So, if I were to say that the area of this whole thing is 1, why does that make sense? Because there's a probability that it lands here, right? And then there's a probability that it lands in one of these triangle areas. You with me? And those all relate to the probability that a dart lands there without me even trying. I don't want to bring into play, well, somebody really good. No. Just, I'm not even looking at the damn thing. I'm just throwing it over my shoulder. So that it's just purely random. Yes?
I think the problem or area of the entire dartboard.
Yes. Yes.
Okay.
So if I made the area of the dartboard, if I considered it to be 1, why does that make sense? Because if I add up all the areas and say there's 1, it's just adding up all the probabilities that it lands in these areas should be 1. If I add up all the probabilities, it should come out to be 1. Okay. I like it. So uniform probability distribution. We're not going to deal with dartboard problems. Sorry if you love darts. A uniform problem. What the hell does uniform mean?
Like a structure.
What's the first thing that comes to mind when I say uniform? School uniform? Police uniform?
Look the same.
Look the same. Everybody gets the same thing. You with me? So uniform probability distribution means that all the outcomes are equally likely. More importantly, somehow, is the idea that this is our first continuous distribution. So think about it. The binomial one that we are just working on, why is it not continuous? What are the possible values for x in a binomial? In that one there that had 44 total people, what were the possible values for x? Almost. 0 through 44, yeah, because it could have no successes, right? But 0, 1, 2, 3, isn't that what discrete is? So that's an example of a discrete probability distribution. Now, let me ask this question again. Let me see. Have you guys ever rode the bus?
Yes.
Or do you know what buses are? When you come to the bus stop, could the bus be right there and you can get right on?
Yeah.
So that could mean you waited no minutes, right? Or if it comes every 15 minutes, and let's pretend like we live in a city where the buses actually are on schedule. Maybe like Germany. When I went to Germany, the trains, you could if it was a second late, people were like, what's wrong? And then Italy is like, it's only off by a couple hours. So I was like, where's this train? And they're like, it's only, calm down, dude. It came and I got on, it was the wrong train. It was great. It was amazing. Come on. All right. So a uniform probability. So does it make sense that if I'm in a city where the bus comes every 15 minutes, but let me do this, but it could be different starting points. You with me? Right, so if I get to the bus stop and it's not there, I could wait anywhere from 0 to 15 minutes. I could get there and get right on. I could get there and it's just leaving. I can get there and it's halfway through until it comes back. You guys with me? Do you guys understand how that is actually the most basic example of this? Waiting from 0 to 15 are uniformly distributed. None of them are more likely than the other ones. If it comes, and this, a slightly better example is like have you ever gone to an airport that was so big you had to get on a shuttle between the terminals?
Yeah.
All right, those are really good for this problem because it's like you're rushing off the plane. You have no idea what time it's supposed to get there. It's just every 15 minutes, and those are pretty regulated. So when you get there, it's equally likely that it'll be there, you can get on it, or it just left and you gotta wait 15 minutes. And everything in between is get the same probability. Is everybody with me? So I know this is gonna look like this. Why is nothing out here? If it comes every 15 minutes, what's the probability I wait 16 minutes? It's impossible, right? If I assume that it's always every 15 minutes, no matter what. Even if it breaks down, I get, this guy who's going to take it, just run. It's part of the strongman competition. Take the bus, run. You seen these dudes, they can do that shit. All right. So what, Jeff? What? So here's the beautiful thing. Hopefully you kind of agree with me that in a situation like darts, I can look at an area as being related to the probability of me hitting that. The larger area has a bigger chance. Is that cool? In general, if I draw a distribution and I make sure the whole thing has an area of 1, then any subsection of that would equal the probability of being there. Any area in a subsection. So what does that mean? Can anybody tell me what this height has to be so that the area of this is 1? If this represents probabilities, I want the full area to be 1 because that relates to all the probabilities adding up to be 1. Are you guys semi with me? So what must the height be so that the area of this is 1? 100. I love you guys. No. How do you find the area? So what is the height? Do we know? What can I call it then? X. Algebra. Saving our ass again. Thank you, algebra. That's what we should be saying. And the area is supposed to be 1, right? What is the area from the picture? What is this? 15. X. So what's X got to be? Why does it make sense that it's the reciprocal of that? Because what's a reciprocal do when you multiply it by the original? It makes it 1. What's the reciprocal of 2/3? 3/2. And what's 2/3 times 3/2? 1. That's what a reciprocal does.
Back to what you said earlier, would the probability of like getting 0 or 15 be different than the probability in between? Is that
All right,
what you
we're
meant?
building up there. Hold on. We're getting there. So let me ask you this. So now that we got our probability situation set up. So real quick, before I get too far away from this idea. What if the situation was this? How tall would it be? What would the height be? Careful.
16.
1/6. Not 1/16. How wide is it? I mean, what's this? 6. So I want to be really careful because this idea is a great one to start with, except for the fact that this is 0, which makes everybody think, oh, it's 1 over whatever that. No. Why is it 1 over 15? Because this is how long? 15. How long is this? 6. That better be 1/6 to make the area 1. Okay. So right here, if I said, what's the probability that somebody had to wait in between 7 and 10 minutes? They had to wait from 7 to 10 minutes. All I have to do to answer that, sort of like if I said, what's probably somebody hits that dart, that little circle in the middle of the dartboard, well, I just got to figure out the area of that little circle. That would be the probability. So I just got to figure out the area of that. So can I draw it in this picture? Yes, 7 is like right there maybe, and 10 is like right there. What is the area of that? You know how tall it is. How tall is it? 115, right? Everything's 115 tall. How wide is it? 3. So what's the area of it? 3 times 1/15. 3/15, which is 20%. 20% chance that somebody has to wait from 7 to 10 minutes. The probability should be easy for a uniform because everybody's got the same probability. All right, this situation. Let me ask you one about this. Yeah. So what's the probability that it's going to be from 5 up to 7? In this one. So if you draw it in 5 to 7, yeah, this is 2. So it's going to be 2 times 1/6. So 1/3, 33.3%. How you guys feeling? So in the homework, that's going to be blank. You got to figure that out. Once you figure it out, they're going to ask you a bunch of different questions. Now, let me put that back. Here's where things get really weird. How many numbers are between 2 and 8?
6.
I love you guys. Let me ask that same question again. Did I put any specification of the type of number? I didn't say how many whole numbers. I said how many numbers are between 2 and 8? Infinite numbers. You with me? This is a continuous distribution. It does not skip values. Oh shit, so that gets really interesting. If I were to ask you this question for this problem here, what if I said, what's the probability that x equals 4? If you continue to look at it in the same way we have been, you'll see the answer. The answer to a probability question for this kind of problem is going to be the area that is represented by it. Right? What was the probability answer here? The area that this represented. If I draw x equals 4, it looks like this. What's the area of a line? How wide is a line? Not. So what's the area of the line? 0. Yes?
Like, if you think about it, like, say, for example, like the bus thing, if waiting for a bus, what's the probability that you wait 4 minutes? It could still technically happen. So that's why I'm just
No,
trying
it
to-
can't. Ha ha ha. Just like, find me somebody who's exactly 5 foot tall. You cannot. You can't. You cannot. Maybe as far as you're interested in measuring them, but we all know that height is continuous. So imagine, if I had 30 poker chips and one was green, what's the probability I get that green one? 1 out of 30. 3,000 poker chips, one green one, what's the probability I get that green one? 1 out of 3,000. Infinite poker chips. It's like a Harry Potter kind of bag here, right? It's like the... No Harry Potter fans? You reach, everything's in there, right? Infinite poker chips, one green. What is the probability I get that green one? 0.
Because you can't technically, you can measure it further and find, like, 4.
It's 1 out of an infinite number of things. I like it. Now, you guys semi with me? It's just the idea that the more things I have to choose from, the less likely it is I pick a certain thing. We know that. There's the most possible things to choose from. Infinite. What's the probability I get a certain thing? 0. Now, side note. Everything I've just said is fine. Because I said it, so hopefully it's fine. Side note, young Jeff, when I first learned about this, I had to look further into this. There's an idea of something called iota. Not iota bank, but have you guys ever heard IOTA, iota? You got an iota's chance of doing something, meaning it's a very small chance.
So letter.
Iota, yeah, it's a Greek letter. Iota is the smallest positive number, in a sense. So it's like the opposite of infinity. All right, so that's all I want to say about this. So it's really, I don't think any of you guys were worried about this, but if each thing is 0 and I add them all up, the whole thing should be 0. So they aren't really 0. They are just the closest to 0 they can be. So in everyday life, it's frickin' 0. If you're at all interested, you can look up the IOTA. If you're not, the answer to that question is going to be 0. So what's probably x equals 3? 0. I like it. What's the probability that x is greater than 2? Come on, you can do it. What values can x take on in this problem? What values can x take on in this problem? 2 to 8. So what's the probability x is greater than 2? 100%. Why is it not different than this? Because probably x equals 2 is 0. So it doesn't add shit if I say it like this or not. It's still 100%. So what's probably x is greater than 8? 0. What's probably x is less than 8? 100%. Yes, maybe. If you look at it from the standpoint of area, you can't go wrong. You don't have to worry about iota or any of this other shit or 1 over infinity. All that crap doesn't mean shit because all that crap doesn't mean shit. It's a very nuanced sentence to go through, but the area of a line is 0. Done. Now, a couple more things that'll let us out like just a smidge early. I want you to realize we're not going to deal with a differently shaped distribution, but in reality, there could be a triangular shaped distribution. Why were questions involving this shape easy? Because any subsection is just a rectangle, and the area is easy. What would a subsection of this be? Like this section. What shape is that? Anybody know? This shape right there.
Trapezoid.
Who is it?
Trapezoid.
Trapezoid. Kick ass. Good old trapezoid is two opposite sides are parallel and the other two aren't. There is a formula for the area of a trapezoid. I'm not going to go through it, but just to show you. So as long as the shape of the whole probability adds up to 1, and I have geometric formulas for the little pieces of it, I can do exactly like what we just did here. If I knew the height of this stupid thing, and I knew the height of that, and all that kind of shit, I can figure out what the area of that is. Yes? Sure, Jeff. Now, what is the most important distribution that we're going to work with? You might not know exactly what the answer is, but let's see if some of you guys do. Normal distribution. Is there a geometric formula that's able to handle that? Is that a trapezoid? Why not? Because one side is all warpy, right? Oh, it was left out in the sun too long. You guys semi with me so far? But the idea doesn't give a shit what the shape is. If I make the whole thing 1, the answer to any probability question between two things or something is going to be the area of that. So when we go into chapter 6, we'll be dealing with this. So what are we going to do since we don't know the frickin' area formula for a wavy dude here? We're going to use a chart that somebody calculated all of it using. We're not going to do this in this class. We're going to use a chart somebody else did using calculus. Because one big thing calculus does is it calculates the area below any function. We're not going to do calculus. We're going to have other people do calculus, and then I'm going to give you the chart of all the numbers. All right. I like it. And that's the next thing. But the real key I'm trying to really hammer in your head is if I draw the distribution and make the area 1, and you saw how to do it uniform, I just make the height so that the area is 1. Any probability question somebody asks me is just the area of that section. That's it. It's almost too nice to really get. So next time I'm going to have a little sheet connecting some more things, and then we're going to get into chapter 6. Oh my God. For a uniform, because the height doesn't change. But for normal,